Hey guys, this is a short video on how to write the equation for parabola if you're given 3 points, and I should say 3 points, and none of them are the vertex. Okay, so let's go ahead and get started. One thing is we're going to consider only parabolas that have a vertical axis of symmetry. In other words, just things like this or this. We're not going to consider sleeping parabolas. Okay, at least not today. Okay. Okay, so if we have the vertex, so finding an equation of a parabola, if you have a vertex and just one other point, is really pretty easy. So imagine we have these 2 points, and I said one of these is a vertex. So let's say the vertex is down here. Well, we already have a couple of parameters that we've used in the vertex form. We have the h and k. So if I just have another point, that x and y of one other point, I have enough to do this. And what I mean is I can take this h and k and I can just plug those in. The only thing I need now is my scale factor. But because I have a point, I can actually fill in these. Okay, so now I know everything except this, which I can now solve a fairly simple equation. And I would get this nice parabola. However, if I have 2 points and I don't have one of the vertices, there's just any 2 points, well, now I can't use this anymore. Because remember, to find the h and k, I have to have the vertex. And in this case, I wouldn't have that. And without those clues, I can't find my scale factor either. Okay? So if you took a look at any 2 points, just any 2 points on a parabola, that could define really an infinite amount of parabolas. So it works for this one here, but it turns around and works for this one here. And again, it ultimately could work for an infinite amount of parabolas if I have just 2 points. So I absolutely positively need a third point. As soon as I get that third point, now I've locked it in. It can't be this. It can't be something, that would have gone like this. It can only be that one unique parabola. So that's what we have to have. We do have to have at least 3 points if we don't have a vertex. So when we have a vertex, we use the vertex form or a graphing form to write the equation. But this way, when we have 3 points, we're going to use the standard form. And this is just a standard form. And in this case, the 3 things we're looking for are not h, k, and a. It's just going to be these coefficients here and this constant. So the quadratic coefficient, linear coefficient, and that constant. That's the things that we need to find. So we have 3 unknowns, but now we have 3 clues. Here are our 3 clues. Okay, so we're going to use a system of equations to do that. So I'm going to put this over here, and the 3 equations we're going to use are this equation. Okay, we're just going to isolate each one of those equations. We're going to assign each one of these to a point. Okay, so just for ease of use, because I think most of us are used to seeing our systems of equations like this, like our variables on one side and a constant on another. So this is what I'm going to do. I'm just going to move it like that. Okay. So I'm going to identify these as 3 points, point 1, point 2, point 3. And if we have those coordinates, we then can plug those into our form there. Okay, so that first equation, I'm just going to take whatever this value is, x1, and I'm going to plug it in where the x's go. Okay, my y, I'm going to plug that in to where my y goes. So there's just one place for that. And I'm going to do that the same for all 3 points. Of course, I'm going to get different x's and y's. Okay, and once I do that, I have 3 unknowns, the unknowns being a, b, and c, and I have 3 equations. So we just solve a system of equation like that. Okay, so let's do an example. Okay, so pause this and copy down the points it passes through. And if you want to try it on your own, try to set up the 3 equations on your own. I'll go right over them. Okay, hopefully you're back. Okay, so let's do this. Okay, so what I start off doing, and again, order doesn't matter at all here, right? So I just pick this as, point 1, point 2, point 3, like this. And I'm going to take this point and fill in this equation and do the same for the other points. So what I mean is I'm gonna do it like this. Here, let me back up 1 here. Okay, we're used to seeing it like this, but because I'm solving for A here, and I actually know what this is, I'm just going to turn that around. So I hope you understand what I'm doing here, right? I'm just moving these here because this is actually going to be a known number, right? That known number in this case is going to be -2. Okay. So that's going to be -2 squared. My coefficient right here is going to be 4. So let's go ahead and do that. Okay, so I'm going to start off here. -2 has to go here, but it also goes here. And then way over here is my -4. Okay, that's my y value. In fact, I can go right along here and go, well, these both are 2. Cool. Can come back in here and go, okay, -4, -4, and then 1, 1. Okay, so notice my x's and y's. Okay, so now I'm just going to rewrite this, kind of clean this up a little bit, right? So that's just going to be 4a. Notice here, -2b plus c equals -4. Okay, and then I'm going to do the same thing here, right? So that's going to be 16a. And notice that -4b, so -4b plus c. I love it. These are always going to be like that, by the way. Equals 2. And then come here, of course, that's just going to be a, right? 1a is a plus, well, like that too, just b plus c equals 2. So now I have my 3 equations, and this is just going to be a system of equations we'll solve. 3 equations, 3 unknowns. Okay. So here they are, and we're going to go ahead and solve these, solving the system. If you already know how to solve the system, go ahead, pause this, and do it. If not, we'll go through it really quickly. Okay, so I'm looking for the a, b, and c. And here's the way that I would recommend doing it, right? Because you're going to solve it. You're basically going to turn this into 2 equations with 2 unknowns. So the first thing I'm going to do is just pick out, and I could take any of them. I want to strategically do it. But the one thing about all these equations, notice the c is always, there doesn't have a coefficient because that is already a constant. So typically what I'll do is I'll pick one of those, I'll pick 2 of these equations out, and I'll go ahead and change this equation to where this is going to be a negative. Okay, so I'm going to take that top equation and just run negative through there, or multiply through by a negative. So now I have this. So now if I just go ahead and add these 2 equations together, I get here. So what I've done here is I've eliminated the c. Now once I've done that, I'm just, I have this equation. I'm just going to, I'm sure right now a lot of you can see that it's, I can simplify that more, but I'm just going to leave it alone for now. Okay, I'm just going to take this and put it aside. Now, notice I didn't change this equation because I'd already, adjusted it here. And now I just take that other equation and we do the exact same thing. We can just add those 2 because remember, these will always cancel. So now I have this equation. And again, notice I can simplify this, okay? But I'm just going to, right now, just choose not to. Just use that. So now once I've used these 3, okay, in a way you could even say that I'm done with these, but let's go up to here. Now I can just solve this. 2 equations, 2 unknown. Now, I think you guys can see where you might simplify it, but let's just say you didn't, okay? And you just went through and we're going to use elimination, so you can choose how you want to do this. So I just choose to eliminate a, and I get to here, and I get b is 3. Once I have b is 3, okay, I can solve for a by plugging b into something here, or plugging it into here, and then we solve for a, and then once I have a and b, to solve c, well, I can just plug it into here, okay. Now, I'm sure a lot of you guys are annoyed by going, but Mr., we should be simplifying this stuff. Yeah, you can. Oops. So if you divided through by 2, in this case, well, if I just left it like this, then it would be 12. We would be here. Would that make it easier? Oh, heck yeah. Okay. But don't feel that if you miss that step, that somehow you'll get it wrong, because you won't. Right. So if we do simplify first and then go ahead and do our elimination, it'll give us the same answers. So now that we have A, B, and C, all we do is just take these are our coefficients, right? A, B, and C. Okay, so we just plug those in, and so now we have the equation of the parabola that goes through those 3 points. Okay, and if we were to look at the actual graph, it looks like this. Okay, guys, why don't you try one on your own? So pause and give this one a try. Okay, and then unpause and we'll see if you got it. Okay, so hopefully you're back. Okay, so I'm going to do just like before. These are going to be my 3 points that I'm going to use. Okay, so I have those 3 points, and now it would just be a matter of me laying out my my equations, right? So, oops, oh, I didn't want to give that away. Okay, so let's just do that. Okay, so starting here, right? And again, I could just say, I know that's not, 8x squared, okay, minus 3b plus c equals 4, right? Because I took this x, I squared it, that's how I got my 9, then it's just what it is, negative 3, and then my c is always going to, in fact, heck, I could do this, right? I mean, I know that's what this stuff is going to be. That's going to be a 0, and this is going to be a 39, right? So on my b's, I can just copy these down, right? So that would be 1b, or just b, and that would be 4. And then finally, I can just go here. 1 squared is just 1, so that's just going to be a. 4 squared is going to be 16, so I'll have this. So any way you do it, the nice thing is this is always going to be consistent. This is always going to be consistent right here. The only thing that I see people make mistakes with is squaring this these x values here. That's usually the only mistake that I see people make. So now that we have this, now it's just a matter of solving this system of equations. And the same thing, it's fairly simple because we can just take, like I can take this one and go negative a, negative b, negative c equals 0, right? Just multiplying through by that. So as soon as I bring this one over, we're eliminating a c. Once I'm done with that and I have an equation in a and b, I can bring this one up, again, instantly eliminating the c, and then have the a and b, and then have 2 equations, 2 unknowns. And that's what we'll get, and that'll be our function, okay, our equation of a parabola. So hopefully this helps you guys. You have a couple of quick concept check homework, and again, check the answers on Google Classroom, and we will catch you later. Bye-bye.